good evening. And today I brought the new series of motion in 1D, and I'll try my best. I will cover all the key concepts into it. So let's start the class. So here, basically 30 minutes will take less than whatever the time it was mentioned. So motion in one dimension. Now here you can see motion in one dimension is basically you can say direct numerical it will come and graphical question. This is important. Graphical question is important for you. Now graphical question we can say like direct numerical average velocity, average acceleration, and instantaneous. So these are a part of calculus we can say, and uniform acceleration. The four topic it will come direct numerical type, and please note those points and you better to rehearse regarding the same area. And the graphical question, we can say finding the value of parameter using graph and converting graph. Is there someday asking kindly convert VT graph into AT graph, fine, or convert XT graph. These are the call conversions that we will see to it. So let's talk about now prerequisite means whatever the knowledge you have to already know this knowledge has to be there at least so you can able to link and connect with the topic very easily. First is vector. I thought you have completed your vector. And the second is calculus. uh, very basic calculus means basic differentiation and basic integration. These topic you better to know about. And a straight line and parabola, I told you 1 y is equal to mx 1 is to 1, that is a equation of plus c. Some equation of a straight line drawing I have already told you. And once you're talking parabola, so y square is equal to 4ax type stuff, the parabola. Fine. So basically parabola means 2 is to 1 or 1 is to 2. This is called parabola, and 1 is to 1, that is called straight line. So better to remember these basics so you can able to explore your time. Now next is average velocity, and so here we can say average velocity. So let's this is the position vector point 1 to point 2. So what is the basic difference from point 1 to point 2? That is r2 minus r1. The average velocity is displacement upon time, is delta r by delta t, that you know already. Here v is a function of time, and once v as a function of time they have given, so we will use average velocity as int. This formula is important. Once it is given time interval, this is for you know discrete value. These two different value they have given, and once a continuous function once they have given, so you will use integration v into dt upon t2 minus t1. This question is important, maybe we will surely discuss afterward. So you have seen in the discussion average acceleration is equal to v2 minus v1 upon t2 minus t1, or delta v upon delta t. And once again one function they have given, so we will use the integration a into dt upon t2 minus t1. Fine. So these are the basic formula that we will going to use. Now next, here you can see good example. If v is given as a function of time, and you have to find average acceleration between time 2 second to 4 second. So what you supposed to do here now, once average word. So once you keeping t is equal to 1, so you will get v2, and v1 we have to put the time t1. So these are the two v we have got. We will simply use the formula v2 minus v1 upon t2 minus t1, and we can get this value. I thought this is one type of question that you better to remember and you can get in your paper as well. So average, we can say in terms of calculation, A average, V average. Now quickly tell me, A average means delta V upon delta T. S average means delta S upon delta T. Now this given data can be asked in a similar way we can calculate the average acceleration and average velocity very easily. Now let's go to the next part. Here we can say instantaneous. Here this is instantaneous. Now how to calculate instantaneous? This is instantaneous. Now instantaneous, v and a, if you are talking about, so if x as a function of t it is given, so we will use basic formula v is equal to dx over dt. Now please start recalling these formula. This is very important. V is equal to dx by dt and a is equal to dv by dt. Now v as a function of t it is given, or x it is given. The two case it will be possible. V as a function of t, v as a function of x. So the basic a t, if it is given a is equal to dv by dt or v dv by dx. This formula is important. And dx over dt, now reverse part, dx over dt, so once you have taken t to the next hand side, so it will become dx is equal to f into dt. Fine. So important part is, if you remember, I told you once we have given x, if we calculate v and a, so for x to v we have to differentiate. Better to remember, this is not very conventional but it is very effective. Now here we can say, if we have given, let's say this is v only, v as a function of t it is given, and you have to calculate x. So we have given and we have to calculate x, so we will move backward or forward. For backward we will need integration. So here you can see this is integration we have done. Integration means t have to transfer to the next right hand side, and then integration sign will going to give you x value. Fine, so better to remember this, and it is very effective as well. Now next important, a as a function of t it is given. So basically a as a function of t, a as a function of v, a, these three cases possible. Like usually when your examination, if you'll see x, so we will apply this formula, v dv over dx is equal to x, because there's no t is involved. And once you separate the variable, so we can say v dv x dx. So this is important formula, and we will see lot of this is important, and lot of numerical that is based on it will surely get. So please revise these various relation and functions and how we can just convert. That will deciding how quickly you can solve the question. Now let's see the question. Now a particle is moving along x-axis with a velocity. This is given function velocity as a function of x it is given. Now always remember velocity as a function of t, velocity as a function of x. So these are two different cases that it is given. And if you want to calculate it, so here we can say this is the calculation, v as a function of x it is given. So once you differentiate with respect to x, so how the differentiation it will be done. Here you can see, let me tell you the differentiation. This is important for you, maybe many they cannot. So here take a d by dx of v square, that is d by dx of 12x minus 3x cube. Fine. Now d by dx of v square, since v is not a function of x, so here we will apply the basic formula, that is d by dx of x to the power n, nx n minus 1. Just consider here this v as a x, so what we can apply, 2v 2 minus 1, and since it is not x, that's why dv over dx it will come. So this is what it has written. So 2v dv over dx, this step is important, and if you have any confusion you can text. So here we can say 2v dv over dx, this is the left hand side, and right hand side you will multiply the d by dx on the both respective terms. So what you will get, 12 dx over dx minus 3 d by dx of x की power 3. And you know, by this basic formula you can convert all exponential formula into differential formula. So I thought you got this point, got this line. Now now what you supposed to do afterward, you have to dv over dx. Now here they have given find the velocity at an instant when the acceleration is not dv over dx, v dv over dx. This is what acceleration. Clear? An acceleration value they have given us, so we will keep this value over here directly. V dv over dx. I told you in a previous slide, v a is equal to we can say a is equal to v dv over dx. This is collectively going to give you a. So I have substituted here, that is 1.5, 12 minus x. Now from there we can get the value of x. As we get the value of x, once I keep this value in the given expression, so what we got it, we can get x is equal to 3 meter per second. Fine. So now here plus minus two possibility were there. This is a value for plus 1 and this is value for minus 1. Minus 1 we got minus 9. Since v square is never going to be negative, that's why this is not possible. The correct answer is 3 meter per second. So this is a correct answer. So I thought you got the point how we proceed. Those question need some practice. To kindly do the practice, we will surely cover the remaining numerical in upcoming. These are the numerical that is still to be covered, and I will surely cover these numerical in upcoming slides. So that will surely going to give you a good sense of imagination and thinking both. So till then, take care. I'll bring the another video because I don't want the video to become very lengthy. So we have completed example number 2. We will surely involve next example in next coming slide. Till then, take care. Have a nice time.